Welcome to the Podkey summary of Validate Your App Intents Adoption with AppIntentsTesting from WWDC 2026. Today's thread is AppIntentsTesting, which is a pretty practical shift in how you can test Siri, shortcuts, Spotlight, and all that system-level app behavior without faking half of it. The big idea is simple. Run the real intents in a separate test process. Keep the tests fast and stable enough for CI, and catch the kind of bugs that usually hide in the seams between your app and the system. And once you see the examples, from seeding data to chaining intents to checking Spotlight and Siri annotations, it starts to feel less like a niche tool and more like something teams are going to want in the default toolbox. AppIntentsTesting is an out-of-process integration testing framework, which sounds a little technical until you translate it into normal human terms. It means your tests can execute real app intents on a device, end-to-end, without importing your app code into the test target. That's important because these features don't really live only inside your app. They show up through Siri, shortcuts, Spotlight, and other system surfaces. So if you want confidence, you want the real path. It also lives in an XUItis bundle. So if you already have a UI test suite, this can slide right in and get picked up by CI automatically. That's a nice detail. Nobody wants a fancy testing story that comes with a 6-step ritual every time you push a commit. The architecture here is one of the more interesting parts. The test runner and the app are in different processes, and intents get invoked by string identifiers, with results marshaled back across that boundary. So there's no shared state, no leaning on mocks, just because it's convenient, and a lot less room for tests that pass in the lab, but don't reflect reality. That setup mirrors how a user actually hits these intents in production, which is exactly what you want if the goal is to test the same code paths. Siri or Spotlight would hit. The way you access the app's intent definitions is pretty clean. You create intent definitions with a bundle identifier, and from there you get the intents, entities, and queries exposed as a dictionary. So the test can discover what exists without linking against the app binary, which keeps that separation intact. Then you call makeIntent on an intent definition, pass raw parameter values, like an enums raw string, and call run to execute it. The return value comes back as an intent result, which is where the framework starts to feel pleasantly less clunky than you might expect. One small but genuinely helpful feature is dynamic member lookup on the result objects. After run returns, you can access entity properties as if they were native Swift properties, so a check can be as straightforward as result.value.title. That works for things like calendar entity and event entity, and it cuts down the usual casting and plumbing that makes test code feel like paperwork. It's a little quality of life thing, but those are the details that make people actually keep writing tests. A really smart pattern in the talk is the use of test-only intents. You can create intents marked as discoverable false and wrap them in debug-only compilation, so they never surface to actual users. That gives you hooks like a seed sample events, intent, which can load deterministic data and put the app into a known state before the real test begins. And that matters, because it helps you skip brittle UI setup, avoid flaky leftover state, and jump straight to the thing you actually want to verify. Basically, less tapping around just to get to the starting line. There's also a solid test-driven development example around an entity string query. The flow is very direct. Write a failing test against entities matching a search string on the event entity definition, then implement entities matching in the query until the test passes. The test checks the number of returned event entity objects and their titles. So it's not just asking whether something came back. It's checking whether the filtering is actually correct. It's a good reminder that intent-related code doesn't have to be this opaque black box. You can develop it with the same feedback loop you'd want anywhere else. One of the more compelling end-to-end examples chains multiple intents inside a single test. You run create event, intent, take the resulting event intentee, and feed that directly into update event intent. That mirrors how shortcuts composes actions in real use. So now you're testing not just isolated commands, but data flow across the whole sequence. There's a neat detail here too. A calendar entity parameter can be supplied as a plain string, and the runtime resolves it through that entity's string query automatically. That automatic type conversion is one of those things that feels almost boring when it works, which is exactly why it deserves a test. Where this really earns its keep is in the system integrations that are easy to forget and hard to validate manually. For Spotlight, the test can call Spotlight query with a string, inspect the event entity results, and confirm newly created events are actually indexed. The talk shows a regression where indexing code had been commented out. The test first confirms no results, creates an event, and then expects exactly one matching Spotlight entry. That's a very real kind of bug. Everything looks fine in the app, but the system-level feature quietly stopped working. The same pattern shows up with Siri-facing view annotations. By running Open Event Intent to navigate to an event view, the test can ask the event entity for view annotations and verify that there's exactly one annotation with the correct title. That uncovered a bug where the code passed a calendar identifier instead of an event identifier, which is the sort of mix-up that can be maddeningly invisible until somebody tries it through Siri. In this case, the failing test made the fix quick and obvious, which is pretty much the dream. The CI story is maybe less flashy, but it's a big part of why this feels useful in practice. Because these tests live in an XUI test bundle, they run in continuous integration without extra setup, and they give you regression coverage for features that normally get tested late, manually, or not at all. They also avoid direct UI dependencies, which helps keep them faster and more reliable across iOS releases than UI-only suites tend to be. So you get realistic coverage without signing up for maximum flakiness, which is a pretty good deal in testing land. The main takeaway here is that app intents don't have to be this fragile edge of the app where everybody just hopes things keep working. There's now a pretty clear path to testing the real behavior in the real system pathways, with enough speed and stability to run all the time. And if a test saves you from shipping a broken Spotlight index because one line got commented out, that's already a very decent day. This episode was generated by Podkey. Create your own at podkey.fm.